In this video, we're going to factor trinomials using the technique for when the leading coefficient is 1, which involves analyzing factor pairs and sums. We're told to factor each trinomial completely, and the first example we see is t squared plus 29t plus 100. So what we're looking to do here is to break this trinomial down into the product of two binomial factors. And so it's going to factor into t plus or minus something and t plus or minus something else. Now, what we need to determine is what goes there. So we're wondering t plus or minus something and t plus or minus something else, what are those two things? So we want to be systematic about this. And the middle term of this expression, t squared plus 29t, and the last term, so the middle term is 29t and the last term is 100, those will allow us to determine how this breaks down into two binomial factors. So what we're looking for when we factor this is we need this last term here, 100. We need the product of two numbers, so we need their product to be 100, and we need the sum to be 29. So we're going to make a table, and we can have factor pairs of 100, and then we'll look at, well, which of those factor pairs have the appropriate sum. Before we make this whole table, it will be helpful to note that if our product is positive, then the numbers have to have the same sign. And if the sum is positive, then they both have to be positive. So both numbers are positive. Coming over to complete our table then, we'll start with looking at what are the factors of 100. So we could have 1 and 100. Those would have a sum of 101 though, which is not the sum of 29 that we want. Next, we could have 2 and 50. Those would have a sum of 52, which is again not the sum that we want. 3 is not a factor, but 4 is, so 4 and 25. And those have a sum of 29, which is exactly what we want. So, when we factor this, we're going to have t plus 4 times t plus 25. And if we want to check, then we'll multiply it through. So we'll check t plus 4 times t plus 25, and we're checking if that's the trinomial that we started with. So when we expand that, we'll have t squared plus 25t plus 4t plus 100, which indeed equals t squared plus 29t plus 100. And that tells us that we factored it correctly. Coming down to this next example, we have 2x squared minus 4x minus 70. Now, that leading coefficient is not 1. And we have more complicated techniques that can be applied when the leading coefficient is 1. But in this particular example, this trinomial has that leading coefficient of 2 as a common factor. So the expression we're looking at is 2x squared minus 4x minus 70. And each of those terms have 2 as a factor. So as our very first step, we want to factor that out. So we'll write 2x squared minus 4x minus 70 equals 2 times, and then inside here we're going to have x squared minus 2x minus 35. Now, this trinomial, x squared minus 2x minus 35, is what we'll want to find the appropriate factor pairs and sum for. So we're going to need a product of negative 35 and a sum of negative 2. And so if we inspect really quick, if we have a product of negative 35, that means one number needs to be positive and one needs to be negative. So we're going to have one positive number and one negative number. Let's come over and make a table now with factor pairs of negative 35, and then we'll check which pairs have the appropriate sum. So to start out, I know one needs to be positive and one needs to be negative. I could do a little bit more inspection and realize that since the sum is negative, the one with the larger absolute value needs to be the negative one, or I can just do both pairs, putting the negative on one and then on the other. So let's do that route. We'll go 1 comma negative 35, that's our pair. That has a sum of negative 34. Another option would be negative 1, positive 35. That would have a sum of positive 34. And so I can see from this that the one with the larger absolute value needs the negative, but again, I can just continue So 1 and negative 35 didn't work, negative 1 and 35 didn't work. I can try 5 and negative 7, and that actually has a sum of negative 2, so I can be done at this point. Those are the two numbers that I want, and so this will factor. The 2 is going to stay out front, and then x squared minus 2x minus 35 will factor into x plus 5 and x minus 7. So when fully factored, 2x squared minus 4x minus 70 factors into 2 times the expression x plus 5 times the expression x minus 7.